Charge transfer and separation are the key processes in solar cells. I will explain how these processes work and also everything that can go wrong. And I will use one specific example of a hybrid inorganic-organic solar cell. And at the end of the video, I'm gonna unveil whether solar cells can be ultra fast. Alright, so let's get started. Solar cells convert sunlight into electrical energy, and they do this by the absorption of the light particles, the photons, which leads to the formation of excitons, bound electron-hole pairs, in the material combination of the solar cell. And then the negatively charged electron and the positively charged hole, they need to be separated in order for us to be able to harvest electrical energy. But of course, many things can go wrong. Let's say we have these two materials, an organic semiconductor and an inorganic semiconductor, and the light excites the organic semiconductor. Then the electrons need to go to the inorganic side, and depending on the semiconductor, it might just not be very attractive for the electron to go there, meaning the density of states may be very low. Another possibility is that recombination of electron and hole is just more attractive. In this way, the energy is not converted into electrical energy, but the light is converted to different light. Besides, also electrons can get trapped either at the interface or in the organic compound, so that they are lost for any charge separation. Or last not least, hybrid excitons can form. The hole remains in the organic molecule while the electron gets trapped at the interface, remaining in the attractive Coulomb potential of the hole, forming a so-called hybrid exciton. Hybrid because one component is in the organic part and one of them is in the inorganic part of the hybrid system. A lot of things go wrong when you use zinc oxide. It just doesn't work very well for light harvesting applications, but no one really knew why this was the case. So this is where we came into play, and we wanted to do some experiments to understand what the fundamental mechanism is behind the malfunction of zinc oxide in solar cells. The challenge here is that all the processes that I mentioned, the charge transfer, the separation, the trapping, the recombination, the hybrid exciton formation, all of this is ultra fast. In order to measure this, you need ultra fast spectroscopy. I've explained this in an earlier video here. Just briefly, the first laser pulse excites the system, and the second one measures the transient properties after a desired time delay between pump and probe pulse. And in the experiments performed here, we used photoelectron spectroscopy, which I also briefly explain in this video. And with these experiments, we could show that indeed there is very strong coupling of the excited state of the molecule to the zinc oxide conduction band, and this is not the reason for the reduced charge separation efficiency, but in fact electrons do enter the zinc oxide, relax really quickly to the conduction band minimum, and then they return to the surface on a 100 picosecond timescale and get trapped, not in trap states, not in defect states, but in hybrid exciton states that have a lifetime of 5 microseconds, which is like really long, and a good reason for zinc oxide not working in light harvesting applications. But wait, you could say, so what? Now they know why it isn't working. Why do I care? The hybrid exciton state is the reason for the reduced charge separation efficiency in zinc oxide, and this is why you may have had a painful time working with a zinc oxide hybrid system. And B, there is hope, because before the charges are being trapped in a hybrid exciton state, they are actually fairly separated, and by clever nanostructuring, core shell structures, or hole scavengers, it is very likely that it's possible to steal away the electron or steal away the hole and thereby inhibit the trapping of the electron in the hybrid exciton state. Now, is this really an ultra-fast solar cell? No. And yes, so ultra-fast processes play a key role, but so they do in any other hybrid solar cell. Any solar cell is ultra-fast because it's based on ultra-fast processes, right? See you next time.